This is our third video on our chapter 7, which is our coordinates and graphs chapter. So let's take a wee look and see what it thinks. So we should be able to read information from a line graph. A graph is a diagram showing the relationship between two varying quantities. So here we have months, and then here we have temperature, average highest temperature in Jamaica over the year. So the graph shows the temperatures in Jamaica over the year. Use the graph to answer the questions. Which month had the highest temperature? You can't see these questions, but it's easier if you just look at the graph and then listen to me. Which month had the highest temperature? That's an easy one. That's going to be August. Which month had the lowest temperature? It's February. How many months have a temperature higher than 30 degrees? Okay, so that's 30 and that's 30, so it isn't those ones, but all the other ones are above that 30. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And they've said higher there, so they're not saying that 30 counts, that's why that's in bold. What is the range in temperatures in Jamaica over the year? So what's range? Range is the highest, take away the lowest. So our highest is 33 and our lowest is 29. 33 take away 29, which is 4 degrees C. Would you expect the temperature range in the UK to be similar or different? Explain your answer. So we definitely know the UK is going to be colder. You're not going to get up to 33 and kind of lowest be 29 and things like that. But what I think about the UK is it a much bigger range. I don't think the gap between February and August is 4 degrees. I think it's much more than that. You know, I would say in February it's going to be the low single figures, maybe kind of a 6 or 7 degrees, the kind of warmest part of the day. Whereas in the summer, then you're hoping it's going to get up to 20 or maybe a wee bit higher. So I think in UK range is much higher, and it's because it's get kind of much colder in the winter, and then not quite as high as obviously it's 33 or anything in the summer, but there's just a lot more difference in temperature. I hope you agree with that and that makes sense to you. And next one, then we look at conversion graphs. So this is to convert, sometimes this is used, so this one's to convert between miles and kilometers, conversion graph between kilometers and miles. Use the graph to find the distances in kilometers. So 20 miles, and we're going to read across and down. We'll just read it across here. In fact, you know what, I'll put in the wee lines. So it says 20 miles, and hopefully you can see that's my 20-mile mark there. I'm going to go across. It's good to show the examiner you know what you're doing. This might get a wee bit cluttered. And so I'm reading that off, and I'm going this way and down. And so that's 20, that's 40, so it must be 30 kilometers. 50 miles. Going across that way and then down there. And so that looks like 80 to me. And then 70 miles. I'm not sure that's going through exactly the right place. This is a tougher one. What do you think? I don't think it's quite hitting right there. I think it's going on to the next one. Let's get it as accurate as you can. I hope I've done the other ones right. That next one along there. So let's see if we can suss out our scale. It looks like that's 100, that's 110, and it's the next one up, but because there's 5 in between 110 and 120, it looks like it's going up every 2, so I think that's going to be 112 kilometers. Use your graph to find these distances in miles. So it's 40 kilometers, and we're now going to go the other way. So it's going to take me halfway, I think. Again, hopefully you agree. I'm going that way, and we're going to cross. So it's halfway, I think, in between. What is it here? 20 and 30. So I think that's going to be 25 miles. And the next one then is 90 kilometers. Again, it's a tough one to read. This isn't really a great graph. So that's 90 kilometers there. I'm going up and then I'm going to go across. So where do we think that's hitting? I can nearly do with my glasses. I guess coming out there. You can agree to agree or disagree. So that's 50, that's 60. Again, one of these signifies 2, so it's 52, 54, 56 miles. I'm going to go for that one then. Which distance is shorter, a half marathon, 13 miles, or 20 kilometers? So it's a really tough call here. So if we go up, it's really hard to read this. There's 20 kilometers there. I'm going to go up and I'm going to go across, and it really looked to me just about the same. If very slightly lower, if you go up there and across, it's maybe just below the 13, which is here. So I think then 20 kilometers is slightly less than 13 miles. So which distance is shorter? I'm going to go for 20 kilometers. So according to that graph, it looks incredibly close. That's a tough question. Okay, we bit down on straight line graphs, and then we're done. So you should be able to find a connection between x and y coordinates of the points in a straight line graph. Copy and complete this table for all the coordinates on the straight line graph. So the point A is here, the x coordinate is 4 and the y coordinate is 2. You see coordinates written like this in the table all the time, and again you'll be coming across that in years to come. For coordinate B, minus 2, minus 1. C, how far is that across? The x coordinate is 6, the y coordinate is 3, 6 and 3. D is minus 4, minus 2. E is another point on the same line. The x coordinate is 8. Write down the y coordinate of E and add it to the table. There's E, and it says the x coordinate is 8. So let's go and we'll put it on here. 1, 2, 3, 4, 5, 6, 7, 8. We're just going to go up until we hit the line. There's going to be E there. Obviously, it's on the line. It says on the x coordinates 8. So there is E, and the y coordinate then is going to be 4. Write down the y coordinate of E. So that's going to be 4. What is the connection between the y coordinates and the x coordinates of the points on this line? You're better looking at the table. 4 and 2, minus 2 and minus 1. That's a bit confusing. Maybe 6 and 3 and 8 and 4. I can see that y is always half of the x. Does that make sense? So we're going to write that y equals half of x. So if you get the x coordinate and you divide it by 2 or find half of it, that's going to get you the y coordinate. F, G, H and I are also points on the line. Write down the missing coordinates. So F is the point 12, the x coordinate is 12, so half of 12 then is 6. So that should be that. For G, minus 10, half of minus 10 is minus 5. I hope you see what I'm doing here. This one, okay, so they're giving us the y coordinate, that's a wee bit tougher. So we're going to need to double it then to get the x one. We'll check that at the end. So if I double minus 24, I'm going to get minus 48 for h. And then double 2x is going to give me 4x. So what would I do? Let's just check the h one. So h is minus 48. Half of minus 48 is minus 24. So I think that one's working. And then half of 4x then would be 2x. So that's worked for us then as well.